Day 1. What you might want to do throughout the course is to choose objectives. It'll give you a goal for the day, and also it will give you a good review to see if you've reached your goal, and you can also prepare for the test to see if, looking at these objectives, if they still make sense. So first of all, today we're going to talk about quadratic relationships, and it's going to be quadratic if the rate of change is linear, which we talked about last time, which means that this rate of change is constant. So that'll be the second rate of change. We'll see that in a moment. We'll talk about standard and vertex form. So at the end, you should know what standard and vertex form is. And for the quizzes and tests, make sure you know those two words. Quadratic is another way of saying degree 2. And if I graph these, they're going to look like parabolas. So here we go. We have the difference here of 1, 3, 5, 7, 9. And we talked about that sequence before, where it was 2 more each time, or odd numbers. But look, if I take the sequence of those rates, they are constant. So this linear constant rate happens after the second step. So the equation for the rate of change changes 2 each time and starts at 1. So the rate and the y-intercept is like the starting point. So we notice the second rate of change is 2, and that was constant. Well, that indicates that the first rate of change was linear. So we look at the first set of numbers, and that rate of change is linear. It's not constant. It's not the same difference each time. But you're right, in the second step, it's going to be the same. But we don't write constant here. Do not. So go ahead and take a look at these tables and go ahead and write down the rate of change. Here's a hint. We can see here that the difference is 2. Okay? And it's going down. -3 is smaller than -1. So if the difference is 2 and going down, it's negative. Here, this difference is 2, but it's going up. So it's positive. The difference here is going up, and it's 6. The difference here is 10, and it's going up, so it's positive 10. And the difference here is 14, and it's going up, so it's positive 14. Here the difference is going up, and it's 4, up, 4, up, 4, up, 4. So the difference, and if it's going up, it's positive. If it's going down, it's negative. Go ahead and do the same thing for the rest of these. Since the second rate of change is the same, this is quadratic. Here, the second rate of change is the same. This is quadratic. But here, the second rate of change is not the same, so it's not quadratic. Here, the first rate of change is constant, and so this is linear. So just remember, to get the rate of change, you subtract, and if the numbers are going higher, it's positive, and if it's going negative, it's going down, it's negative. This way, you don't have to worry about the order of the subtraction. You'll just understand that if it's growing, it's positive. If it's getting smaller, it's negative. And you can subtract in any order you want to. Now when you have to fill in the blanks yourself, you might want to do it what you might think of as backwards. So the rate of change here is 3. The difference is 3, and it's getting larger. Here the difference is 9, and it's getting larger. And so the second difference is 6. If we want to make it quadratic, all the second differences have to be 6. So here's what I mean by backwards. We're going to do this part of the table first. So we add 6, add 6, add 6, add 6 to get the differences. Well, here the difference is 3. Here the difference is 9. If this difference is 15, then I add 15 to get 22. If this difference is supposed to be 21, I add 21 to get 43. And if this difference is supposed to be 27, I add 27 to get 70. And sure enough, I hit the last number. So again, let's remind you about the differences. The difference here is 5, but it's getting bigger. That's why it's positive. The difference here is 3. It's getting bigger. That's why it's positive. The difference here is 1. It's getting bigger. But here the difference is 1, but it's getting smaller. The difference is 3, and it's getting smaller. Okay. Well, like I said, we're going to do it backwards, so we get the differences of -2. And so we can get the numbers in this column by subtracting 2 each time. And then taking these differences and coming up with add 5, add 3, add 1, subtract 1, subtract 3. All right, so equations of quadratic functions. This is vertex form. And this is standard form. You've seen these before, but let's just take a quick review. Yes, these two a values are the same. And if a is positive, the parabola goes up. If the a value is negative, the parabola goes down. Many of you might remember that if it's negative, we flip the graph, and then what used to go up now goes down. Okay, you might remember that HK is the vertex. In this picture, the vertex is to the left and down. That's why they're both negative. Here the vertex is to the right and up. That's why they're both positive. It's just true for this diagram. It's not always true. We have x-intercepts, where the graph crosses the x-axis, and the x-intercepts always are some x value and then 0. Okay, because if you're on the x-axis, y is 0. X-intercepts, x is something, y is 0. Now here's the one that's important. For the y-intercept, x is 0, and we're looking for y. X is 0, and we're looking for y, because we want to know the y-intercept. Well, look at this one. If x is 0 and x is 0, these are gone, and I just have c left. So I could say that the y-intercept is 0c. The y-intercept is 0c. It'll always be that number at the end, but we can see that because when I plug in 0 for the x, the first two terms disappear. So here's the vertex form, and here is the standard form. Now this might look familiar. If I have standard form and I want to find the x-intercepts, well, that's when y is 0. Aren't I solving a quadratic equation then? And if I'm doing that, I would use the quadratic formula. And I'm sure you learned a song or something at the middle school. But it's much easier to find the x-intercepts if we're lucky to have a factored form and these are just the x-intercepts. Because if I plug in R1, this becomes 0, multiply by 0, the whole thing is 0. Same is true for R2. All right.